If we have a continuous function f on a closed interval ab, there is a procedure for finding the absolute maximums and minimums. First, find the critical numbers and the values of f there. Second, find the values of f at the endpoints. And finally, the largest among these values is the absolute maximum. The smallest among these values is the absolute minimum. Let's take a look at an example. Find the absolute maximum and minimum values of this function on the interval from minus 1.5 to 2. The first thing we want to do is find the critical points. Okay, so let's find the derivative. Okay, now this is a polynomial and it's defined for every real number. So there's no place where f prime is undefined. So the only other place to check is when the derivative is 0. So set the derivative equal to 0. And solve for x. Let's pull out a 4x. Okay. So we get these two factors. So 4x equals to 0 and x squared minus 1 equals to 0. Solve each one for x. Okay, so these are my critical numbers. Okay, let's plug in these x values into f. Remember what f is. F is this thing, so plug in 0. Plug in 1. Plug in -1. Okay, and now we need to check the endpoints. Okay, the left endpoint is -1.5. Plug that into f, and we'll get approximately 3.56. Plug in the right endpoint, 2. Okay, so now we have the critical points and the endpoints, and we simply look for the largest one. Okay, so here we see 11 is the largest. So we have an absolute maximum at x equals to 2, and the maximum value is 11. Now look for the smallest one. Okay, so the smallest number is 2 here. and it occurs twice, once at 1 and another time at -1. So these are absolute minimums. Okay, let's look at the graph of f. Okay, from -1.5 to 2, we see that the maximum occurs here, and it occurs at x equals to 2, and the maximum value is 11. Okay, and here we see some absolute minimums at -1 and 1. Okay, and the absolute minimum value is 2. So this verifies what we had here. There were 2 absolute minimums occurring at -1 and 1, and there was 1 absolute max at 2. Okay, let's look at another example. Find the absolute maximum and minimum values of this function on the interval from -9 to 9. Okay, let's look for the critical numbers. Find the derivative of f. Okay, here we have a quotient, so we're going to apply the quotient rule. Okay, so the bottom times the derivative of the top minus the top times the derivative of the bottom. All over the bottom squared. Let's simplify this a little bit. Okay, the 2x cubes cancel out. And we end up with this. Now let's see where this is undefined. The only time that this is undefined is when the bottom is 0. But since we're taking x squared and adding 9, this part will always be positive, and squaring it will always make it positive. Okay, so there's no place where this is undefined. Now the only other place to check is when f prime is 0. So let's set that equal to 0. Solve for x. Let's multiply both sides by the denominator. And then solve for x. Okay, so that's the only critical point. Alright, now let's start plugging in f of 0. Okay, remember our function f. This is our function here. So if I plug in 0, I get -9 over 9, which is -1. Okay, so -1. And then let's check the endpoints. I get 0.8. Check the other endpoint at 9. That gives me the same thing, 0.8. Okay, now let's look at which value is the largest. Okay, we have 0.8. So we have absolute maximums at 2 places, minus 9 and 9. Okay, so we have absolute maximum at x equals to -9 and x equals to 9. Now find the y value that's the smallest. Here we see that -1 is the smallest, so we have an absolute minimum at x equals to 0. Okay, let's take a look at the graph here. Okay, now the absolute minimum occurs here at x equals to 0. This is verified here. And the absolute maximum occurs at -9 and 9. And we saw that the absolute maximum value was 0.8. Okay, so it's a little less than 1 here. Okay, so this graph verifies what we found earlier. Okay, let's take a look at this example. Find the absolute maximum and minimum values of this function on the interval from -1 to 6. Okay, so let's look for the critical numbers. Calculate f prime. Okay, here notice that we have a product, x to the 2/3 times x minus 8. So we need to use the product rule. Take the first term, multiply by the derivative of the second, plus the second term times the derivative of the first. I just simplified this a little bit. I brought the x to the -1/3 down here, made the exponent positive. Okay, now let's see where this is undefined. Well, this part would be undefined if x equals to 0. Okay, so x equals to 0. That's one critical number. Okay, everywhere else this expression is defined. So let's check what happens when you set it to 0. Okay, and let's solve for x. Multiply everywhere by x to the 1/3 power. That gets rid of the x to the 1/3 here. Now here the exponents add, so I get x to the 3/3, which is 1. Okay, so that's x plus 2/3 x minus 16/3. Combine the like terms. Multiply everywhere by 3 to get rid of that denominator. Okay, and solve for x. Okay, so we have this 16/5 as a critical point. Now, let's start plugging in the x values. F of 0. Okay, remember our function is given by this. So if I plug in 0, I get 0. Let's plug in 16/5. That's approximately negative 10.42 if I plug it in my calculator. Let's check the left endpoint, -1. I get -9. Plug in the right endpoint, and I get approximately -6.6. Okay, so let's look at which is the largest here. Okay, since these numbers are negative, the largest is 0. Okay, so we have an absolute max at x equals to 0. Now let's see which is the smallest. Okay, so it looks like -10.42 is the smallest. So we have an absolute minimum at x equals to 16/5. Here's the graph of our function. So we see that we have an absolute maximum at x equals to 0. And the lowest point here is here. So the absolute minimum occurs somewhere around here, which is 16/5, which is close to 3. Okay, so the graph verifies what we found earlier.